Hey guys, welcome back. Today we're going to do more with integration and get into some of the details of the rules. Okay, so hopefully you remember that an integral is represented by the area between the curve and the x-axis. And if the area is below the x-axis, this is given a negative value. So the first question, what is the integral from 0 to 5? That means we want to find this area, and because it's below the x-axis, we have to give it a negative value, okay? So to find that area, you have a couple choices. You can either chop it up into triangles and squares and do it that way, or you can use the area of a trapezoid, either way. So if I treat it like a trapezoid, formula for the trapezoid is 1/2 the height times the sum of the bases. So it's 1/2 of the height would be 2, and the two bases would be 5 and 2. Half of 2 is 1, so that would be 7. So the area here is 7, but because they didn't ask what is the area is always positive because it's a physical, tangible thing, but they didn't actually use the word area. They said, what is the value of this integral? So since this is below the x-axis, we say that its value is -7. Okay? Okay, next one. What is the integral from 4 to 6? We start at 4, go to 6. We want to find those two areas and assign a negative value to the one below the x-axis. So a formula for the area of a triangle would be 1/2 base times height. So this one would be 1/2 of 1 by 2. So 1 times 2 is 2. Half of that would be a 1 for that area. The other area is 1 by 4. So 1 times 4 is 4. Half of that would be 2. So the value of this integral would be -1 plus 2, which is 1. Okay, last one. The integral from 0 to 10. Well, we already did the area of the first trapezoid from 0 to 5, and we knew that was 7. So now we just have to find the area of the other one. Again, you can use the formula for the area of a trapezoid, which you have to know anyway, or cut it into triangles and rectangles, whatever you want. All right, so I'm going to use trapezoid. It's 1/2 the height, which is 4, times the sum of the two bases, which is 5, plus, what is this guy? 2. Half of 4 is 2, so it's 2 times 7, 14 for this total area up here. So that means the value of my integral would be -7 plus 14, or 7. Okay, so remember, when they ask you to evaluate an integral, they mean what is the area between the curve and the x-axis. Anything below the x-axis is given a negative value. Okay, now let's talk more about what the integral actually represents in the real world, okay? If they give you a rate, they give you a derivative is a rate. Focus on the units. If they give you miles per hour is the equation, or f of x, okay? And they ask you to integrate it, then what you're finding is total miles, okay? If they give you feet per second and you integrate it, then what you're finding is total feet. If they give you people per hour and you integrate it, then you're finding total people, okay? So they give you a rate and they ask for the total of something. That's when you know to do an integral. So here are a couple of examples. I don't know where the equation is. There it is. Okay, read this to yourself, nice and slow. Make sure you understand what's being given. Okay, neon flashing lights are supposed to go off when you see the word rate, or if you see the word per, because that implies a rate also, like feet per second. So they don't have to give you the equation written in derivative format. They could just call it f of t if they wanted to. And often they do on the AP exam. So, but you have to know that they're giving me a rate, and let's figure out what the units are of that rate. This is how fast items are being sold. Okay, so items per week would be the rate, items per week would be the units that represent this rate. Okay, but again, the word rate, as soon as they give me the word rate, I think, oh, they're going to ask me for the total. All right, well, look at the question. They say, what is the total number of items? That means integrate to find the total number of items. So we're going to be integrating this. Okay, DT is a technicality. You don't get marked off if you don't write that on the AP exam. They want to know what is the total in the first 5 weeks. So we are going to integrate this from 0 to 5. Okay, that's the part I need you to get used to. That's the whole point of this whole second semester. Okay. All right, now on the AP exam, you can write that, or you can write it, the integral from 0 to 5 of whatever they have called it, if that's quicker. Now, we know how to integrate this by hand, so we can do a power rule and integrate it by hand and then plug in the 5 and the 0. But I also want you to know how to put it into your calculator, and it's quicker to write it like this on the AP exam and then put it in your calculator if it's a calculator question. Be sure you know how to do this both by hand and in your calculator. Okay? By hand, quick review, we would add 1 and divide by the result. So we would get a negative t cubed. Add 1, divide by the result, and we would get 18t squared. I would evaluate that from 0 to 5. That means plug in 5 for my t's, plug in 0 for my t's, and subtract. Okay, go ahead and finish that math. I'm going to skip ahead because I know you know how to do that. I'm going to skip ahead to how you put this in your calculator. So I'm going to be putting this original expression into my calculator. So I'm integrating this equation from 0 to 5. I'm going to plug it in just like we wrote it here. Okay? So you might need to write down that equation on your paper. All right, to integrate it from 0 to 5, it's going to look just like this. Here we go. In your calculator, first, you're going to hit the math button. Okay, the math button. And you got to arrow down to option 9. Okay, option 9 is the one you're looking for. Integral. This should pop up. And then you're going to plug in exactly what we did on the other, exactly what that equation looked like, except you don't need to worry about it having variables of t's. You can deal with x just as well. And you plug in just like it looks, okay? Now, if math 9, if it doesn't pop up like this for you, then let me know. That means you have to change your settings on your calculator. All right, so you should be able to get that on your calculator. And if you need me to show you how to change your settings, let me know. All right, here's another example. Oh, let me go back to that last one. That answer that we got, 325, what are the units? Make sure you write the units when you're dealing with word problems. It helps you figure out what you have found. So we got an answer to this question. We got an answer of 325. Well, what was it? 325 items were sold. Okay? And you want to write the units, not because you have to. Sometimes you have to. They'll tell you when you have to. You want to write the units because it helps you know what you have found. And on the AP exam, these questions usually have multiple parts, A, B, C, and D. And you may need to use this somewhere else later in the problem. So if you write down what it is, it helps you remember what you found. All right, let's see another example. Read this one and see if you can figure out why there's an integral, okay? Okay, keyword rate, gallons per hour. Okay, write an expression that represents the total amount of oil. Amount of oil in gallons. So we're going to get the total gallons. So we're in the first 5 hours. So we're integrating from 0 to 5, 20 plus 4t, dt. When we integrate that either by hand or with your calculator, that answer is going to represent the total amount of gallons of oil. Since I already reviewed how to do it in the calculator, I'll review this time doing it by hand. So this would be, when we integrate it, 20t plus, add 1 to the exponent, you would get a 2, and divide by 2. Evaluate it from 0 to 5. Remember, you plug in the 5 first, then the 0. Plugging in the 5, I get 100 plus 5 squared is 25 times 2 is 50 minus zeros. So we get 150. Go back to your units. If this is gallons per hour, we found gallons of oil. Okay? Easy peasy. Just paying attention to when to do it. You're getting the total. Okay, now we're going to do some integration rules that are mostly common sense. You really don't need to write these down, okay? The first one. This one says that if you change the bounds, the numbers in your integral, if you reverse this, then it's the same as putting a negative out front. So if ever you want to reverse the bounds, you can just switch a negative out front. Well, if you think about it, if you had 3 to 5 of f prime of x, and you integrate to get f of x, and you plug in the 3 and the 5, you get f of 5 minus f of 3, whatever that is. Okay? Well, if you reverse it and you change it to 5 to 3, hopefully you can see that this would then just be in an opposite order. So in order for it to be equivalent, you would have to change the sign. So when do you use this? You'll use this in the future when you're doing area on a graph because you'll want the numbers to be in order. But the short of it is, what you need to get out of this, okay, if for whatever reason in your future, if you ever have to reverse the bounds, then throw a negative out front and it's equivalent. Okay? Next one. This is stupid. If the bounds are the same, then the number you plug in, if the bounds are the same, then the number you plug in, you're going to plug it in twice and subtract it, and you're going to get 0. That's dumb. Okay, that's also very common sense. Okay, next. Something we've been doing all along, so it's kind of dumb also. If you have a number in front of the function, a constant, you can move it out front if you want to. I don't find that one very useful. I usually just leave it there. Next one. This is something we've also been doing already. When you integrate a function, you integrate each term. We've already been doing that. So we integrate each term. So if you need to rewrite it like that, you can. I don't know, whatever. I don't really need that written out as a rule either. Now the next one is pretty important. Okay, this one is very visual, and this one is the big one, okay? So you don't need to write it down, I don't think, but here we go. If you think of this as area, this is saying if you go from A to B and get the area under the curve, and then you start again from B and go to C, then that's the same as going from A to C. Let me show you that one graphically. If I integrate, I have a curve, f of x, whatever it is, and I integrate from A to B, okay, then that would be this area. But then I add to that the integral from B to C. B to C maybe is this. Well, then that's the same as the total area from A to C. I think you can see that, okay? So I kind of recognize that one by you're trying to get rid of the middleman. Okay, now let's try to apply those rules. Okay, see if you can do these on your own. Hit pause. This is also very common on the AP exam. They don't really tell you what the function is that you're integrating. They just tell you pieces about it and then ask you to use those rules to figure it out. So pay attention to what's given. This one's h of x, and these are both f of x, okay? They want to know the integral from 4 to 1 of f of x, but what's given is 1 to 4. So since the bounds are reversed, make it negative, make it its opposite. Answer would be 2. Okay, next one. Okay, if we integrate whatever the integral of this is, when we integrate it, I keep doing that, I'm so sorry. Okay, if we integrate this one, whatever that integral is, it doesn't matter because I'm going to be plugging in a 4 and a 4 and subtracting. So therefore, obviously, this one is 0. Next. Okay, give it a guess. Don't let me do it for you. Give it your best shot. Hit pause. So this is what they think you're going to write down, but you can really do this one in your head, okay? So you don't have to write this, but this is applying that rule. The integral from -1 to 1 of f of x is 5, and 2 times that answer would give me 10. I don't have to write all that down to figure it out, though. This integral of h of x is 7 times 3 would be 21, so the total's 31, and I don't really think that was that tricky. All right, let's see if I can trick you on the next one. Okay, take the time for you to figure it out. Take the time. Hit pause. Okay, hopefully you saw that this is one of those where you try to get rid of the middleman. Visualize area under a curve, okay? Going from -1 to 4, well, I don't have one that does that, but I can go from -1 to 1 and then add to it from 1 to 4. So the integral from -1 to 1 is 5, and from 1 to 4 is -2, so this answer is 3. So do this one now on your own. There is one in here that I pretty much guarantee you're gonna get wrong, and I'm setting you up on purpose, okay? So I'd like you now to try A, B, C, and D legit on your own, and you'll probably get one of them wrong. Okay, let's see how you did. By the way, the notation on that first one, that's the same as f of x plus g of x. Hopefully you figured that one out, okay? I think you probably were able to do all of these on your own. Let me give you the answers. Here's B. Did you get that one? I'll show that. What the heck? You kind of have to do some subtraction, but again, you want to visualize this as area. If the integral from 1 to 6, okay, if the integral from 1 to 6, visualize that with area. From 1 to 6, that total area is 23, okay? From 1 to 4, however, that area is 11. So if it's going to add up to a total of 23, then what does that leave you to go from 4 to 6? So basically it's 23 minus 11, which should have been 12. You can also do that one algebraically if it's less confusing. I could say the integral from 1 to 4 plus the integral from 4 to 6 has to equal the integral from 1 to 6. Okay, remember we're getting rid of the middleman, just setting it up like that. Then change one of them to a variable, the question. This one is my question, I'll call that an x. So this we know is 23 plus my question has to equal, oops, I put the 23 in the wrong spot. 1 to 4 was 11. That was here. Plus the question has to equal 23. That's the other way to do it if you're not as visual, okay? Part C, you probably had no trouble with that one. That one's kind of common sense, which means part D is the one I predict you got wrong, and I will show you why in a minute. Here's the answer. Not 19. It's 23. Since I know most of you, if you did this honestly, most people do get the wrong answer, and this is a common AP question. Let me make sure I show you why. The answer is not 19, it's 23. Let me show you why. So this is one where you actually do want to visualize splitting it up, okay? You can't just add 2 at the end of your answer to this part. And here's why. That dx matters. You still should be integrating this 2. Does that help you figure it out? Okay, the integral from 1 to 4, yeah, that is 11. But this is another integral. I still have to integrate it because of that dx after it, which means what it really equals is 2x. I'm integrating it with respect to x. It's 2x evaluated from 1 to 4. Then you got to plug in the 4 and the 1 and subtract. So we have an 11 plus, plugging in a 4, we'd get 8. Plugging in a 1, we'd get 2. So it's 11 plus 6. Did I do that right? I feel like that's wrong. Hold on a second. I really don't want to redo this whole video, so hopefully you guys have found my mistake. This is g of x, not f of x. So going way back, this part right here, 1 to 4 of g of x, that was 17. So this should have been a 17 right here and a 17 right here. Now it looks familiar. Okay, 17 plus 6, 23 is the final answer. So that's it for today. Hopefully you guys are doing all right. Let me know if you need anything. Please be sure to message me. If you have any questions at all, don't be shy. I don't mind making videos explaining whatever it is you're missing, okay? I've made a worksheet using the old calc book that we used to use, and so that's on Canvas. Good luck. Bye.